Okay, good morning once again. My name is Dr. Anayo. I'll be your course lecturer for this course, Computing System or Introduction to Computing Systems. That is csc701. We'll look at the course outline. The course outline. This negates all the things we actually need to do in this course. And the essence of it is that some of you can even read ahead. To get yourself aligned in the business of the day. I believe that some of you may have or may not have been in a computing background. For a PGD to take place, it is more of collaboration of different people from different fields or background. Some of you may have passed, maybe come through HDD. And so far, this PGD is the prerequisite for you to do your master's. You must fall in here. And some of you may have done computing courses. Probably you have taught class or a second class lower. You will also be in these categories. Then some of you, okay, may come from a different background of academic discipline. And you decided to switch over or cross carpet to a computing community. So we also expect you to be here. However, we assume that everybody is quest to gain a new knowledge. Whichever background you came from, we see everybody as one. And as far as this course is meant for you to take, you should be able to, or we should be able to justify the essence of the course. So on the course outline, we'll look at the introduction to computing systems. We'll look at operating systems, the concept. We'll also look at the system software development. The system software development. So this is a one of the major components of the course outline. So in addition to this, we also look at emerging trends in computing system. Emerging trends in a computing system. So after that, we'll look at the parallel and distributed systems, followed by embedded systems. It's more of the introductions. So we'll look into this because we actually want to launch you in the era of computing. Computing system is a very broad area. So, but on this course, we wish to alert you, wake your mental capacity, your mental prowess to begin to revolve around a computing paradigms. So that's why we are now introducing you into this concept. Then follow up is we look at case studies and some probably sample projects you might be interested in. Then finally you can look at some of the area for further research, because you can visit this link. We can also I will also share some other materials, including my lecture notes. So at least looking at some of the textbooks combined with my lecture notes. So we'll use hybrid materials to drive this knowledge. Now, we have to look at the first course outline, system software development. Okay. Let me check something. Let me check this a minute. Okay. Just a minute, Dada. Let me separate this from the further system. Oh, can you see my screen? Can you see my screen?
Yes, sir.
Okay. Sorry, I was trying to, the thing was mixing up with the embedded system, those of the masters. So I just have to look through it because I was sharing it and I discovered that there are interlaps. Okay. As I was saying, The major part of what we are discussing here lies in the fact that computing is a very broad areas. It's a very broad areas. So like I was sharing with you on that I discovered that course material, the course outline is not only for you that is that have that. So is the one that concerns you is the first three parts here: introduction to computing system, operating system concept, and system software development. So and then emerging trends in computing system. So that is the these are the most ones that involves okay. All of these, more of the introduction part, we'll look into it. So the major part of it is we actually want to look at the reintroduction to software system, the introduction to software to computing system, which is this part. We'll look at introduction to computing system. That is the first course outline. In this course outline, we'll look at overview of computing system and their components. We'll also look at evolution of computing system. And finally, role of computing system in a modern society. Okay, so going forward, we'll look at I believe my screen is visible.
Yes, I see.
Oh, good. All right. Now, one may think is, or may ask himself or herself is, computing system, computing system, computing system. We have had so many informations, or when people will be talking about computing system. Okay, before we dive deep into this lecture, I want to share with you my teaching philosophy. My teaching philosophy is very simple. It goes in this way. Everyone is a teacher and everyone is a learner. Everyone is a teacher and everyone is what is a learner. It means that the class is going to be interactive. Everybody will contribute or participate or actively. There is little slight difference between PGD and undergraduate. Even though most of who probably pass through computing department in the undergraduate level may have here some of the terminology we'll be using. Nevertheless, we are doing this because it is essential for us to look into them. And some of you have been a little time that you graduated. Maybe you are from industry or you are in an academic environment. But it's over time that you can sit down like this and read for like 1 hour, 2 hours. But I want to encourage you. You just sign up as a student with a registration number. It means that you are now going to reason and behave like a student. What does that mean? You start carrying book up and down, both in the office, both in your working place, and both in the house. Some of you maybe probably you have a family. Now you have to now begin to match the tasks, the responsibilities of your home, your academics, and your work. Sometimes you even carry book. Your children will carry book. Two of you will be like, mommy, daddy, this is I'm carrying book, you are carrying book. Or I tell you are reading. Are you a student? So you see, as far as you are part of this class, you now begin to behave like one, behave like student. That's studentship mentality will begin to drive into your brain. So I know that is normal for you to sit and read like 1 hour or even 30 minutes before you know you are introducing sleep. But I will encourage you, keep doing that. Gradually, your body system will be reconfigured because you have a lot to read, you have a lot to do, assignment in all different courses, and you must to do them. This is semi-undergraduate. PGD is semi-undergraduate. So that is that. And if I may ask, how many of you are probably working in a university environment or a teacher, or you are in industry, or you are probably self-established? So is any of you in academics among you? Can we introduce ourselves and our working place, because it's very important so that it will guide me to know the level at which I can, or the pace I can take the lectures or the courses. Can we do some probably just an introduction, introduce yourself and probably where you are working, so that we'll familiarize with ourselves and see how we can drive each other together. Am I communicating?
Yes, ma. Okay, good morning, ma. And my name is Achi Cornelia Matthew. I worked at Development Control, FCTA.
Okay, FCTA. Okay. Development control, do they have anything like schools or is it kind of an organization?
No, no, it's not a school, ma.
Okay, so when did you graduate? When did you graduate?
2022.
2022. Okay, somehow your memory is still fresh. Okay, okay, Chuku.
Good morning, all.
Good morning.
Okay, my name is Okoye Florence Ogechuku, and I am an insurance broker.
Okay, when did you graduate? Which year?
2019.
Okay, 2019. HND or cross carpeting from another
HND.
department? HND.
I know HND.
Then,
Yes, sir.
oh, okay, that's good. Is it by me? Are you from HND or? Okay, HK Peter.
Okay, sir. My name is HDK Peter. I graduated 2018. I do business. I sell products online. Yes, sir.
Okay. So I see Felicity. Felicity, can you unmute your mic and speak to us? It's like she joined and then maybe left for her normal business. I think she don't answer places. Ioma, are you with us?
Yes, sir. Good morning. Hello?
Yeah, Felicity, are you with us?
I'm with you. Can you hear me?
Loud and clear.
Good morning, Doc.
Good morning.
Hello. Good morning, everyone.
May we know your name and the year you graduated?
Okay, my name is Felicity Dodo. I have a HND in computer science. I graduated 2009.
Okay.
And I work here in Veritas University, the Secretary of Computer Science Department, Veritas University.
Great. Okay. Ekene Dirichukwu, Iheoma, can your network allow you to speak to us now?
Can you hear me, sir?
Yes.
Okay, good morning, sir. Ihoma Augustine Ekene. I'm a graduate of Computer Science, Federal Polytechnic, Bida. I work as admin in Discovering Talent Academy.
Okay. All of you are welcome to these contemporary classes. You see, it's good that we understand ourselves, understand our background, because as I said earlier, this is a platform or a bridge. Thank you. This is like a bridge. PGD is like a bridge that want to catapult you to another level. It's a bridge that is going to launch you to a level that you begin to master all you are doing. And that is called PGD. After which the next, you see yourself into master's degree before you gradually swindle into the final echelon of academics called PhD. So now we have been hearing about computing systems, and this computing is no longer a new thing to us, because when you talk about computing, you are talking about every mechanism or scenarios or approach through which you can execute your job seamlessly. So many things are involved. I will try as much as we can to give ourselves some of the real life scenarios to enable us to understand this course we are in. Because this is the heart of it all. The computing system is very broad. Do you know that now we are having it as a faculty? Some people before they have it as a department. Before now, now we are having it as a faculty, computing faculty. You discover that we are doing it as a course now, but this is more of the introduction to understand what are under that's the same umbrella. Because under the computing system or computing faculty, we have so many, anything that has to do with technology comes in. Even part of engineering are under computing. In some school, what they have is school of what? Computing. It means both computer science, computer engineering, artificial intelligence, cyber security, embedded systems, computer engineering, all of them are put together under the faculty of computing. Nevertheless, we want to look at those things that drive computer system or computing systems. What are the things that drive them? What are the elements that without it cannot work? Now, going forward, we look at the component of computing system. We have central processing unit called CPU. Let me tell you, There are three basic components of a computing system. We have the hardware component, we have the software component, the hardware component, the software component. These are the two basic components of a computing system: hardware component and software component. And the third part of the component that cannot be separated is human component. If you put it three categories, we have one, the hardware component, the software component, and the human component. These three spouses areas are the integral part of the computing system. One, the hardware are the physical components that drives all the physical parts we can feel or touch. But the software component is opposite of what the hardware component. That one is soft part that you cannot feel or touch. That one is like a set of codes that drive the hardware. That one is like an instruction that do what, or that drives the hardware. Then in another part of it, we have human components. If hardware and software exist, they cannot operate itself. It requires you and I to coordinate it. Computer cannot function without human beings. Even somebody may argue, we have robotics. Some robots can work with or without human intervention. But who developed that robot? Does that robot, come from heaven or originated from nowhere? Human being developed it to work. Therefore, the three integral parts that cannot be separated is the hardware, the software, and the humanware. I just say human component or humanware, hardware, and the software. I repeat, hardware, software, and humanware. So it is an important part. So we'll take them bit by bit. We'll talk about the CPU. I want to explain to you how CPU works. You may just cram it as a CPU is the central processing unit or the brain of the computer that executes some instructions. But let me tell you something. If you know how human being works, human brain works, during our secondary school, when we were doing from integrated science to biology or biology, when we are told or we are taught that about cell, organ, and system. Cell is the smallest unit of life where every other thing's life emanated from. We have organs and different parts brought together or different developed by the system. I mean, cells gave birth to organs, and we have different organs of the body system. We have the sensory organs, maybe like eyes, the skins, and the rest of them. Then, in that part of that, we have heart as one of also organs. We have brain. your one that drive by medulla oblongata. Let me tell you something. If you understand how the human brain works, you cannot match it with what? Computer brain. In our biology, we were taught that human brain is a central part of the body system that drives and coordinates and controls every other component or organs of the body. Brain is a central part of the body system that control and coordinates every other organ or system in the human body. That is why you remember that once anything that happens to your brain, you begin to malfunction. And what they call it an insane or mad people or lunatic people. The difference between you and the abnormal people, they call it insane or mad people, is because of the brain, nothing else. So when their brain begin to malfunction, they become abnormal or mad people. But when your normal brain is working, you become a normal person. The same way computer is. That brain of the computer is called CPU. So when you understand how the brain works in human beings, the same way CPU works in the computer system. Both the arithmetic logic units that helps you to perform some functions of like calculations and control other instructions in the computer are also fall in these categories of central processing units. Then can we now look at the memory? Can we now look at the memory? When you talk about the memory of the computer, that helps to store data and instructions, where that brain of the computer, which is CPU, needs to access quickly. Memory is like your heart. It's like your medulla oblongata that the CPU need to work with. Memory is like your IQ, your EQ, your intelligence quotient, your emotional quotient. That brain drives to think, for you to think well. That is how memory is. It's just a storage device that helps to store data and instruction. If I may ask, what is data? What is data? Can someone differentiate data? We have data, we have information, but my question is, what is data? Because we said that memory stores data and instruction. What is that word data? Can someone explain what is data and or instructions?
They are raw facts, unprocessed facts.
Unprocessed facts.
Yes, sir.
Then in our conventional English speaking, when we say instruction, what instruction means? I need someone's is this Suliyat? Am I correct? Your name is showing Suliyat. What's your full name?
Yes, sir. Suliyat.
Suliyat. I don't make me say go call you cat. So let me take the last three words. Yat.
Suliyat.
Let me take the last three words. later, or Yat. So Yat, what in your office, somebody gave an instruction. What is that? What do we understand as instructions?
It's the same thing as a data.
But here we see that memory stores data and instructions.
It's also to direct or to give an order.
Okay. It's more of to direct or give an order.
Yes, sir.
So, and if there is any instruction, maybe somebody can verbally tell you every Monday morning, there must be a morning prayer. It's an instruction. Or your boss
Yes,
comes
sir.
in and say, he's giving you instruction, please don't let anybody to see me at usual time. It's an instruction.
Yes, sir.
It's an order. So now all these instructions are being laid down. When you put them together, those instructions begin to harmonize them. Combine with maybe say when somebody say 1, 2, 3, it's not an instruction, it's a data. So, and when there is an instruction put together, when you begin to put them together, maybe you type them and put them in your system, it becomes also a data or information. So when you put them together, this memory helps you to store them or save them. As we are talking now, the system is recording our discussion. Through, at the end, it will not be saved in the memory. So I want to let us understand how this computer works. So when you talk about memory, we have 2 categories of memory. One of it is what they call random access memory and read-only memory. Random access memory, RAM. One day I was teaching my students. I asked them, what is RAM? They said the RAM is one big mesh chip that, for instance, during the Ramadan, you see so many rams every corner of the street that their father always used to buy ram. So that is the meaning of RAM. I said, good. For you to understand what physical RAM is, then we can then look at it in the computer dimensions. Please, I'm having a class. I'll call you back. I'm having an online class. I'll call you back. So when you look at it, is that in a computer system, it has a different meaning. It's more of volatile. When you begin to, when you are typing something in your computer, when you are processing something, it's at the periphery of what? In the RAM level. As we are talking now, the RAM is responsible to capture our voices and our interactions. But if at the end it was not saved, the whole discussion or recording disappear or will disappear. When you begin to type something on your computer, as you are typing, the RAM helps to hold those information. But when you close it without saving it, it will disappear. How do you solve that problem? RAM comes in. When you are typing something, once you save it, the ROM helps you to keep it in the computer system. That is why we say ROM, read-only memory, is a non-volatile memory that stores firmware or boots up instructions. It helps your information to be stored permanently in the computer system so that when there is interruption, power outage, etc., it will help to keep those information. I'm taking time to explain this so that you'll be able to understand what the computing system is all about. You'll be able to understand how do you now process your information. How is computing is revolving around the entire discipline. You begin to understand in depth gradually how computer advent of computing system is taking over the entire world. Every part of human endeavor are being facilitated by help of computing system. So gradually you understand a lot of things that we actually need to do or know. Now we'll look at the third part, input or output devices. What you call I/O device or devices, which helps you to do what? Send and receive information from the computer system. It helps you to do what? Input or get out information out from the computer system. I/O devices. Those devices that help you to enter information to the computer system at the same time help you to get information from the computer system. Understand this. Input device is different. Output device is different. Input and output device are also different. This makes some students not get the desired mark. Some of you, when you look at input and it's common now, even you just overlook it. But when they ask you in the exam, you begin to write some, mix the information, thereby making you to lose the mark. If I ask you, define the following with example: input device, output device, input output device. They are not the same. If I may ask, what is input device? Okay, Chiku, are you with us? Okoye. Okoye, are you still here or you just log in and then? Okay, Chiku, can you hear me? Not at all.
Jesus, sorry. I can hear you. Sorry.
What is
went
input
to
device? If you can hear me, what is input device?
Input device are the piece of computer, the mouse, the scanner, the microphone, webcam, and all that provide data and control the system.
That provide data and control the system. Then what of output device?
Output device are what the system are able to process and then bring out.
Okay. Then what is input output device? I/O devices. What can you say is the input-output device? Yama is not is present, but body absent. Okay. Now, I want to say that we've been able to establish what is input at devices. Those devices are helping to enter information. And we also talk about output devices, those information that help you to get information out from the computer system. Now we want to look at input output devices. Are those devices that perform both functions? Input output devices are those devices that perform the same function as input and same time perform function as output. One device performing the same function. Who can give me one example of one of the devices that can perform the same function? So I took time to teach you and not to lecture you. If I want to lecture you now, if I don't even finish the whole thing. But I just want us to understand this so that by the time you come up, you will not be like the same way we did it in undergraduate. They will just tell you input and input, they will just speak the whole grammar they go. But at this moment, we want to dip a bit to understand what we actually need to do or learn about it. Who can give you one example of input-output device?
Your touch screen.
Touch screen? What do you mean by touch screen?
You can touch to input and then it displays output.
I need more example for clarity. Yeah, one example.
We have microphone. Microphone captures both audio and converts it to digital data.
Microphone. I quite disagree with you. Microphone only capture, but does not give out.
What about USB?
Scanner.
Eh?
Scanner.
Yes, I agree with you. Scanner, digital scanner, not other scanner. Digital scanner will help you to, scan and also probably help you to see it. The digital scanner can play in that role.
USB.
USB. USB only used for transfer. It can only help you maybe for input. It cannot help you for output.
Okay. Joystick. It's used for gaming, also for gaming device.
Joystick can only help you to enter and play, but it cannot help you see what you're doing.
Okay.
What about printer?
Printer can only help you see what you have done. It cannot help you to enter. Okay. You see, it's good that we understand this because in the exam, probably I may give you list different devices and ask you to categorize it, both input, output, or input, output. I may ask you to list examples of I/O devices. Just hold on, let me answer my HUD. Hello, ma.